this video, I'm going to show you how to find zeros using a graphing calculator. For these examples, it says state the possible rational zeros for each function. Then use Desmos or a graphing calculator to help you factor the polynomial function completely and find all zeros. So they're wanting us to do three things. Find the possible rational zeros, which remember is always constant divided by leading. These are your plus or minus p over q values. And then we're going to use Desmos. To get to there, you'll go to www.desmos.com/calculator to help us factor the polynomial function completely. So that's the second thing they want us to do. And then we want to find all of the zeros. So if I look at example 1, I have f of x equals x cubed minus 7x squared plus 11x minus 5. My highest exponent is 3. So that tells me, that I'm going to have 3 zeros. So when I solve this problem, I should have 3 solutions. My constant is my term without my variable, and that's 5. Factors of 5 are 1 times 5. My leading coefficient is 1, and the factors of 1 are 1. So my possible rational zeros is, 1 divided by 1 is 1, and 5 divided by 1 is 5. So I have 4 possible rational zeros. Positive 1, negative 1, positive 5, and negative 5. So what I can do from here is I can type this into my graphing calculator, and I can see which of my possible rational zeros are actually zeros. So let's go to Desmos so I can show you what I mean. In line 1, I'm going to type in the equation that I was given. So that equation is x cubed minus 7x squared plus 11x minus 5. So here you can figure out your zeros one of two ways. By looking at your graph. So here I can see that 1 is a 0 and that 5 is a 0. So right now I know that 1 and 5 are both zeros from my calculator. Oops. Well, I know that there's 2 zeros, right? So that's 1 is a 0 and 5 is a 0, so that's 2. And I need 3. If you think back to the very first day of this unit, oops, I want this. If you think back to our very first day of the unit, we learned that whenever we have a tangent, that's when the graph touches and turns around, like how it does here at 1. This only happens when your multiplicity is 2. So because this is tangent at 1, you know what happens there. So we can say, okay, we have x equals 1 with a multiplicity of 2 because it's tangent there. And then x equals 5 happens once. So those are 3 zeros. That's the third thing they wanted. We also want the factors. So the factors, well, if 1 is a 0, then x minus 1 is a factor. It has a multiplicity of 2, so that happens twice. And then if 5 is a 0, then x minus 5 was a factor. And so those are your factors. Now I did say that there was another way of how to do this, so let's go back to Desmos so I can show you that. If you have a hard time finding your zeros from the graph, another thing that you can do is look at the table. So if you hit this settings gear up here, there is an option to select a table. And what I would do is I would delete everything that is in that table right now. So just go ahead and delete it. It's coming up as undefined because there's nothing there. What you're going to put in the table are your possible rational zeros. So my possible rational zeros were 1, -1, 5, and -5. Where it is 0, that's where it's a 0. So 1 works and 5 works. Notice how -1 is not a 0 because that gives me -24. And -5 is not a 0 because that gives me -360. So if you struggle at finding your zeros by looking for the x-intercepts, you could also plug in your possible rational zeros here to figure out which one of those works. Let's try this again looking at example 2. So on example 2, I have g of x equals x cubed minus 3x squared minus x plus 3. My highest exponent is 3, so that tells me I'm going to have 3 solutions, or 3 zeros. We always want to begin by finding our possible rational zeros, so that's what I'm going to do, constant divided by leading. In this problem, my constant is 3. The factors of 3 are 1 and 3. My leading coefficient is 1. My factors of 1 are 1. So my possible rational zeros are 1 divided by 1 is 1. And 3 divided by 1 is 3. So I have 4 possible rational zeros. +1, -1, +3, and -3. Let's go ahead and plug this into Desmos to see what we get. So, here we go. I'm going to type in this equation. So I have x cubed minus 3x squared minus x plus 3. And you can click right on your zeros. Remember, zeros are your x-intercepts. So I have 3 of them, -1, +1, and 3. Again, if you don't like doing it that way, you could look at your table. My zeros were +1, -1, 3, and -3. And I'll just delete these ones that are down here. So you can see here that 1 is a 0, -1 is a 0, and 3 is a 0. -3 is not a 0 because we get -48. So either way, by looking for your x-intercepts or by looking at your table of values. Again, to get to your table of values, you click on the settings gear, and then there's a table for an option there. So again, my zeros, which is the third thing they were asking for, were -1, +1, and 3. We also want to know the factors. Well, if -1 is a 0, then x plus 1 is a factor. If +1 is a 0, then x minus 1 is a factor. And if 3 is a 0, then x minus 3 is a factor. Let's look at example 3. I'm going to go ahead and plug this one into Desmos. So I'm going to have x cubed plus 9x squared minus 21x plus 11. And here I know that I am going to have 3 answers. Because my highest exponent is 3. And right now I can only see 1. So sometimes it just might help to zoom out. And as soon as I zoom out a little bit, I can see another one. So I have -11 and I have +1. When I look at -11, it crosses that. And then at 1, it's tangent because we touch and turn around. So -11 happens once, and 1 happens twice because it is tangent there. So if I go back to my notes, I have x equals negative 11 and x equals 1 with a multiplicity of 2. So that is the third thing that they wanted. I still need to go back and find my possible rational zeros. So let's see. My constant for this one is 11. Factors of 11 are 1 and 11. My leading coefficient is 1. My factors of 1 are 1. So my possible rational zeros are plus or minus 1 and plus or minus 11. The last thing that we need to find are the factors. Well, if negative 11 is a 0, then x plus 11 is a factor. And if 1 is a 0, then x minus 1 is a factor. 1 happens twice, so that means it has an exponent of 2. And let's look at example 4. For example 4, my highest exponent is 3. That tells me that I am going to have 3 zeros here. And so my constant is 5. And my leading coefficient is 1. So my possible rational zeros will be plus or minus 1 and plus or minus 5. So from here, I'm going to plug this into Desmos and see what I get. So I have x cubed plus 5x squared minus x minus 5. And I can see right here on my graph that I do in fact have 3 zeros, 3 x-intercepts. They are at negative 5, negative 1, and positive 1. And so those factors will be x plus 5, x plus 1, and x minus 1. Go ahead and pause this video and try examples 5 through 8 on your own. See how far you can get with each one, and then when you are ready, resume the video and we will go over them together. So if we look at examples 5 through 8, we are doing the same thing as we did on examples 1 through 4. We want to state the possible rational zeros for each function, and then we want to factor each polynomial function completely using integer coefficients. So that means no decimals and no fractions. And then we want to find all zeros using a graphing calculator. So possible rational zeros, factor, and find the zeros. So if we look at example 5, our highest exponent is 3. So that tells me that I'm going to have 3 zeros. So let's go ahead and begin by finding our possible rational zeros. My constant is 2. The factors of 2 are 1 and 2. My leading coefficient is 2. The factors of 2 are 1 and 2. So my possible rational zeros are 1 divided by 1 is 1. 1 divided by 2 is 1/2. 2 divided by 1 is 2. And then 2 divided by 2, which is 1, which we already have there. So I have 6 possible rational zeros here. Plus or minus 1, plus or minus 1/2, and plus or minus 2. So I'm going to figure out which of these are actually zeros by using my graphing calculator. So I am going to go over to Desmos, and I am going to type in this equation. So I have 2x cubed plus 3x squared minus 3x minus 2. And I can see my zeros here. In the directions, they told us that we wanted integers and not decimals when we factor. So I can see that I have zeros at negative 2 and 1. Another way that can help me with this is I can look at my table of values and plug in my possible rational zeros. So my possible rational zeros were 1, -1, 1/2, and -1/2, +2, and -2. And I can see that I get 3 zeros by looking at my table. 1 is a 0, and -1/2 is a 0, and -2 is a 0. So I have 3 zeros right here from my table. I can also see those 3 zeros here. So -2, -1/2, and +1. So now I want to write the factors. If, let me write it this way. If -2 is a 0, then that means that x plus 2 is a factor. If -1/2 is a 0, well, what factor could give me -1/2? Well, let's think about this for a second. We have something with x. If it's negative, then I would have to subtract, or I would have to add here to be able to subtract. So I know that I'm subtracting 1 because I have +1. And then if I'm dividing by 2, the opposite of dividing by 2 is multiplying by 2. And let's think about this. If I were to solve this for x, I would subtract 1 on both sides and get 2x equals -1, divide both sides by 2 to get -1/2. So the factor here would be 2x plus 1. And then last but not least, if 1 is a 0, then that means that x minus 1 was a factor. So here are my factors. So when you have a fraction, just work backwards. How would you get there? Whatever is in your numerator is what's going to go here with the opposite sign. Whatever's in your denominator was being multiplied by x. Let's try example 6. So on example 6, my highest exponent is 3. So that tells me that I'm going to have 3 zeros. My constant is 2. The factors of 2 are 1 and 2. My leading coefficient is 2. The factors of 2 are 1 and 2. So this is the same constant and leading that we had on example 5. So I'm going to have the same possible rational zeros. So my possible rational zeros are again plus or minus 1, plus or minus 1/2, and plus or minus 2. Let's plug this into Desmos and see what we can find. So I have 2x cubed plus 5x squared plus x minus 2. And here I can see 3 zeros. Those 3 zeros are -2, -1, and 0.5. If it helps you, you could plug in your possible rational zeros into your table. My possible rational zeros were +1, -1, +1/2, -1/2, +2, and -2. So from my table, I can see that my zeros are -1, 1/2, and -2. So again, those zeros were -2, I think -1, and +1/2. Let me just double check. -2, -1, +1/2. Yep. And then from here, I want to go ahead and write my factors. So if -2 is a 0, then that means x plus 2 was a factor. If -1 is a 0, then that means x plus 1 is a factor. If 1/2 is a 0, then that means 2x minus 1 was a factor. And again, that's because if I have 2x minus 1, to solve for x, I would add 1 to both sides. I would have 2x equals 1, divide both sides by 2, and get x equals 1/2. So that's how you write your factors using only integers as your coefficients. So these are the 3 things that we were looking for on example 6. Let's try example 7. So on example 7, first thing I'm going to do is find my possible rational zeros by doing my plus or minus p over q values, which is my constant, divided by my leading. My constant is a 1, so my factors of 1 are 1. My leading coefficient is 3. The factors of 3 are 1 and 3. So my possible rational zeros are going to be 1 divided by 1 is 1, and then 1 divided by 3 is 1/3. So I have 4 possible rational zeros here: positive 1, negative 1, positive 3, and negative 3. Let's plug this into our graphing calculator and see what we get. Again, I know I'm going to have 3 answers because my highest exponent was 3. And so I have 3x cubed minus 7x squared plus 5x minus 1. And from here, I can see that I have a 0 of 1, and then I also have this decimal, and we don't want decimals. We either want integers or fractions. So let's go to our table and see what our table can tell us. My zeros, my possible rational zeros were 1, negative 1, positive 1/3, and negative 1/3. So I can see that I have 2 zeros here. 1 is a 0, and 1/3 is a 0. So that must be this point right here. So let's see. We cross, see if I can zoom in here. We cross right here at 1/3, but we touch and turn around here at 1. See how we go down and then we come back up. So we're tangent here at 1. So because we are tangent at 1, that means that 1 has a multiplicity of 2 because we touch and turn around there. So again, our zeros were positive 1/3 and positive 1. Positive 1 has a multiplicity of 2 because it is tangent at that point. That's where it touches and turns around. If 1/3 is a 0, then that means 3x minus 1 is a factor, because you would have to add 1 to both sides, which would give you a positive 1 here, and then you would divide by 3, giving you the positive 3 down here. And then if 1 is a 0, then that means x minus 1 is a factor. It has a multiplicity of 2, so that is squared. And then let's look at this last one. Let me just fix this. This was the third thing they wanted, and this was the second thing they wanted. And then on example 8, we're going to begin by finding our possible rational zeros. Here my constant is 1, and my leading coefficient is 4. Factors of 1 are 1. Factors of 4 are 1 times 4 and 2 times 2. So my possible rational zeros are 1 divided by 1 is 1. 1 divided by 2 is 1/2. And 1 divided by 4 is 1/4. So here I have 6 possible rational zeros. Let's plug this into Desmos and see what are actually zeros. So I have 4x cubed minus 4x squared minus x plus 1. And I can see that I have zeros in 3 locations here. And so let's see. If I go to my table, my zeros were positive 1. My possible rational zeros were positive 1, negative 1, positive 1/2, negative 1/2, positive 1/4, and negative 1/4. Here I can see I have 3 zeros. 1 at 1, 1 at 1/2, and 1 at negative 1/2. These all cross at each of these points, at each of these zeros. They're going straight through. None of them are tangent. So my zeros again are at 1, positive 1/2, and negative 1/2. From here, we want to write our factors. If 1 is a 0, then x minus 1 is a factor. If 1/2 is a 0, then 2x minus 1 is a factor. And if negative 1/2 is a 0, then 2x plus 1 is a factor.